Today we are going to learn elementary statistics. Let me ask you, have you ever learned statistics before? Well, don't be too much worried about the statistics. It's a simple concept. Today we will just look at what is the statistics. Okay, so don't worry, let's go together. So today we have three learning goals. The first one is know concepts, the difference between populations and samples, and there are some sampling techniques. Today we will cover that. And the second concept, you need to understand how to calculate descriptive statistics such as mean, median, mode, and standard deviations. The last one, I want you to understand the concept of statistical process control. So shortly we say SPC. Alright, let's look at the population and sample first. What is the random variable, by the way? Here you can see two images, flipping coins and rolling a dice. Let's assume that the rolling a dice is a random variable and we want to have a number 1 here. Okay, then what is the probability if we rolling a dice and get a number 1? Okay, how about the flip the coins? If you flip the coin and you want to see tail or head, it's your random variable. So random variable here is how you defined in a certain situation. Flip the coin, that is a random variable. Rolling a dice and get some number from the roll dice, that is a random variable. So flip the coin case, it's definitely 50%. So probability of random variable X is 50%. How about the rolling a dice to have a number 1? That is 1/6. Okay, that's simple way. So that is we call it probability. Okay, is it random? Yes, it's random. So in random case we can say probability. Alright, what is statistics? Then statistics is a quantitative measure to things that have occurred in a random manner. Okay, like flip a coin, that is totally random. Rolling a dice, it's a random process, and we want to make some number, okay, to represent that probability. Okay, that we call statistics. Okay, but not only the quantitative measures, but also we also include the collecting data, analyzing data, and interpret the data. This whole process we can always say, oh, this is statistics. Okay, then let's look at a type of data. There are 4 different types of data according to their how much information they included. The very low level data is nominal data. It's gender, blood type, or colors. We cannot compare which blood type is larger or slower, or we cannot calculate those values. How about the ordinal data? Ordinal data is rank or educational degree. There is some orders, right? So we can compare it is same or lower or higher. That's the case, and that is we call it categorical data. Let's look at the continuous data. Continuous data has more information than the categorical data, such as interval data. The interval data, temperature. Temperature, we can compare which one is lower or higher, and also we can sum or minus, things like that, but we can't do multiply or divided by them. Ratio data has more information, more degree of freedom to use to compare the lower or higher or plus or minus. We can also multiply 2 variables such as income, age, and weight. Those information have much more information compared to nominal, ordinal, and interval data. Okay, that's it. That's the 4 type of data. The question here is that it's an interesting question. So we want to know the average stature of the in 20s in the United States. Okay, what is the average stature of 20s in the US? That's the question. what is the average stature of 20s in the US? There should be more than thousands of people in the US in their age 20s, right? That is populations. The population is always exist, but we don't know the average of the population because it's really hard to collect all the people's stature information in the United States. So answer is we don't know, because we don't know the populations. There is a population, but we cannot recruit all those people to measure the stature. That's almost impossible. So what we can do is a sampling approach. Let's take some people in their 20s, and then we can say, okay, this sample, the stature is, let's say, 171 centimeter on average, so that we can say the actual population of the 20s in the United States, their stature will be 171. It's very close to the sample. Okay, so this is the US adult population. Let's select some samples. Let's say the students in the classroom in their age 20s. Okay, this is a sampling approach. So again, the population is total collection of elements. It's too large to examine. But how about the sample? Sample is a subgroup of a population and they represent of entire population. Then the following question is how we define the sample is good enough, or how we select the sampling, how we select the sample from the populations. That's the questions. Okay. So how many sample is good enough to represent the whole population, and how to select the samples. Okay. All right. But by the way, the rule of thumb is at least you have to select 30 samples. That's at least numbers. So you have to say, you have to collect the 30 people to say, okay, this sample has this much stature as an average, so that we can say the population average will be similar. So we should have at least 30 data to say this data, this average will be meaningful or representativeness. Okay. Alright, how we do the sampling? The basic method is just sampling, okay, randomly select. This is the population for the US Army data. We have almost 2,000 data sets here. There are including female data and the male data. You can see the x-axis shows weight and the y-axis shows the stature here, right? So it looks like there is an increasing pattern. It makes sense, and it looks like positive correlations between weight and the stature. Okay, it looks like these patterns. Alright, so now we are going to select 30 samples from this population. Let's select the 30 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and let's assume, so okay, we select 30 people here randomly. Okay, so these 30 people selected by randomly, it's very random. We call it, this data set is unbiased because it's selected by randomly. But how about if we select here the female data only? Okay. It's possible, even though we select the data randomly, sometimes we it's a very rare case, but it's possible only female data were selected. That's possible. So we want to avoid this situation. Why? Because this sample is only represent the female data, not male data. So if we calculate the average or standard deviation using this data, then it's a little biased because it's only female data. Alright, we want to avoid this situation, so we try to select randomly the data using a certain techniques. Let's look at the data set. Stratified random sampling. Here we have female data and male data separately. Okay, so male data there are 1,700 data, female 2,200 data. let's select the 15 people for each. Okay, so 15 people for female data. Okay, and then again we can select the 15 data for male data sets. Alright, in this case we can equally sample the 15 people for female and male each. We stratify the data by gender. Okay, so this data set is stratified by gender. It's a simple way, but we also can consider the density. Okay, before we go to density, let's look at the density here. So here we have a data, and this is the distributions. Alright, and this red line indicates the mean of stature and the mean of weight. Okay, so there should be here, this person is has an average weight and average stature in the entire populations. And you can see this is the histogram. Histogram shows the frequency how much deviate from your mean. Okay, so here the data, we have a small number of data here, and still increasing. It's increasing, and decreasing, because as you can assume, around the average there should be many people, because their weight and their stature is somehow in the middle. The middle should be has a more density than the side or edge of the histograms. So here mean is 69.4 kilogram for weight, and for stature here you can see the mean is 168.6 centimeter. Then what is variance? Okay, variance you can calculate by this equation, but I don't want you to remember this. You don't need to memorize this equation. I will give you this equation in the midterm, but you have to understand the concept. The variance is how much your data is deviated from the mean. Okay, so this is mean and this is mean, and how much data you have deviated from the mean. If it is large, then your data is quite widely distributed from the mean. If it is narrow, then your data more close to located to the mean. Okay, the standard deviation is the root of variance. Okay, root of variance. That's it. Alright, so this is a histogram as I explained before. The y-axis shows number of data and the x-axis shows weight in this case. Okay, so if there are too many people, the histogram bar is highly located here. Okay. So here you can see area A, area B, and area C. So that I want to say the area B has more density than A and C group. Okay, it's a simple concept, right? There's nothing harder to things. Remember, okay? Alright, let's do the stratified random sampling and considering the density. Okay. Select the sample by gender and the populations. Let's say we made a grid here. There are a grid system, and the yellow box, this area has more dense, okay, compared to other populations, because this is close to the mean area, so that there should be many people would be here. So we want to collect 3 people for each yellow box. Okay, 3 people, and then we want to select 2 people in this case. The more lower cake side, more higher cake side. Okay, and then we want to collect only 1 participant, 1 samples from this area, because in terms of density wise there is a small number of population located here, so that we can just select 1. But here in the middle area we can select 3 people to represent the populations distributions. Okay. Alright, so histogram again. So this is a very useful graph to look at how much your data distributed. Okay, So for example, this x-axis shows stature, right? We don't know the average. Oh, here we have average. The average is 168.6, and this is frequency, the number of how many people are here. So for example, 168 should be around here, right? So that the people on average area is much higher than this area and this area. This is the histogram. So x-axis shows independent variable. Sometimes it can be a stature or a weight, and the y-axis always shows frequency. So there is a simple quiz. Which distribution has the smallest standard deviations here? Distribution C, distribution A, distribution B. So which one has the smallest standard deviation in this case? As you may know, the A, because you can see the distribution. As I said, that the standard deviation is measured to explain how much your data deviated from the mean. If it is the smallest, then it's very close to the mean. Okay, so distribution wise, it's narrow. That is the smallest standard deviation. How about largest mean? Largest mean among these three distributions, as you know, yes, C has the largest mean. So you can see the midline can be the mean in here. Process A, process B has same mean, but process C has a more larger mean, but they have larger variations. Okay, it's a simple concept. So you probably remember these figures. So this is a totally good example. It's a very good example to show what is mean and the standard deviations. So for example, here look at see, this is not repeatable and not accurate. This one. So you can calculate the mean is way far away from the target, and if you also calculate the standard deviation, it's way from the mean. So if you say this is a mean, this is how much deviated from the mean, so standard deviation wise this is also very big. But how about this figure? This figure, the average, the mean is a little bit not little bit, way far from the target, but standard deviation, they are very close to each other, so it's repeatable. The repeatable means standard deviation is very low. Okay, the accuracy here is accurate but not repeatable means the mean of this this 6 data is close to the target. And how about the standard deviation? Standard deviation is somehow it's very large in this case. The perfect case here is precise case. It's accurate and repeatable. That means the average of these 6 samples is close to the target, and they are very close to each other. That means the standard deviation is low. You can see the next video, the machine versus human. The machine is quite repeatable and accurate. There are 63, 95, and 99.7 rule in normal distribution. This is we call it normal distribution. Why? Because in the nature, most of data set will follow this kind of distribution. Think about the stature of human beings. All right, there should be a mean here, and many people are positioned around the mean. And if you go smaller and larger, there should be the number of population should be decreased, right? So this is a normal distribution. We call it the bell shape, the normal distributions. Alright, here in this slide I wanted to say is that the range of the one standard deviation plus minus 1 sigma, that we call this is sigma, meaning is standard deviations. If we can calculate one standard deviation in normal distribution, that means this range will cover 68.2% of your populations, of your samples. That's a rule of thumbs. in terms of product probability. How about plus or minus 2 standard deviation? Usually, if you calculate 2 standard deviation, 95% of your data would fall in this area. How about 3 standard deviation? It covers your 99.7%. It's huge. Okay, so you can calculate mean and the standard deviation, and you know the concept. That's good. But here, I want you to know about what is mu. Mu is the mean of a population. But as I said earlier, we cannot calculate the mean of a population because it's harder to get all the population in the United States in their early 20s or any other data set. Population is populations. We don't know the population, but we can assume using X bar. The X bar is average of your samples. So let's say, okay, this classroom has 30 people and the 30 people's average stature is 171. So we can assume the mean of mean stature of U.S. population would be similar to the 171. So that is statistics. That is statistics. Have you heard about the Six Sigma concept before? So Six Sigma is a very almost very well-known philosophy in manufacturing site, and there are many books are published about the Six Sigma, how to achieve Six Sigma. So I want to introduce the concept of Six Sigma here. We have a normal distribution here, and you can see mu plus 1 plus 2 plus 3 sigma, and here we can always save. We can also say 4 sigma, 5 sigma, and 6 sigma. 6 sigma should be around located here. Okay. What I wanted to say is, if your process is in 6 sigma, then you can make a good product. How much percentage is here? You can see 2 sigma covers 95%, 3 sigma covers 99.7%, and the 6 sigma, it covers 99.9999998%. So there is a very small number of possibility to generate malfunctioning product. There is no perfect machines. There is no perfect machine. Sometimes machine can generate some bad product defeats due to certain reasons, but you don't want to make many defeats or many malfunctioning product, right? So your machine in your manufacturing process, your machine in the shop should make a high quality good product for this amount of probability. Okay, so this is the Six Sigma concept. How we can achieve Six Sigma concept? We have to define the problem, measure the problem, analyze the problem, control the problem, and improve it, and keep continuously. We call it DFACI, DFAC. So we can keep continuously do this process to achieve Six Sigma goal. Okay, that is Six Sigma. Alright, this is very important concept for your midterm exam too. There are 3 different average. Okay, 3 types of average. So mean is, you probably know what is mean. Mean is just sum up all the data and divide by the number of data. Okay, that's a simple way to calculate the mean. How about the median? Median is middle value in the list of your numbers. Okay, middle value. So here you can see the data number set 1 contains 1, 2, 3, 4, 5, 6, 7. In this case, mean is 4. You can just sum up and then divide it by 7 in this case. Yeah, it's 4. How about the median? Median is middle value. Okay. But how about here? We don't have a middle value here. 1, 50, 70, 100. Alright, in this case, we can choose 2 values in the middle, 50 and 70, and divide by 2. Okay, so here median is 60. How about in this case, what is the median? Median is in the odd number. We can select the middle case. In the even number, you can select two variables, two data in the middle and divide by 2. In this case, let's say, okay, 20 is a median. How about the number 4? You can select the two data, divide by 2, so 50. Mode is a little interesting. Mode is sometimes your data set doesn't have mode, but sometimes your data does have mode. Okay, here is there a mode? 1, 2, 3, 4, 5, 6, 7. The mode should be repeated number. There is no repeated number, so it's not available here. How about the data number set 2? Not available. Number 3? Not available. How about the data number 4? Yes, the 50 is repeated. The mode here is repeated. By the way, it looks like here 50, 50, 50, 50, 50, and 10,000 seems like an outlier, right? Alright, anyway, let's move on. So now, so far we learned what is the concept of population, what is the sampling, how to do the sampling, and then we also learned how to calculate mean, median, and mode. From now on, so we are going to look at some SPC chart. Okay, SPC chart. So I wanna simply check whether you understand that this standard deviation and mean concepts well or not. Okay, let me ask you the questions. Here we have some machine. This machine build a bolt. Okay, the bolt length, the length of the bolt should be 1 inch, exactly 1 inch. 1 inch is this size. Okay. Process C, the distribution is looks like this. Process A, process B. Which process line is the best case in this among these three processes? All right. In terms of standard deviation, it looks like A is very narrow. But how about the mean? It's a little bit deviated from the 1 inch, right? How about process C? Process C is the mean wise, it's very close to 1, but the standard deviation wise very large, so you can generate some bad product. How about process B? Process B has, in terms of mean, is close to 1, but in standard deviation wise it's a little bit closer. It's close to the mean, but it's not as much as A, but it's better than C. So in this case I would choose process B. How about A versus C? As I said, A has a small standard deviation, B has a large variation. But if I were you, if you ask me which one is better than A and C, I would choose A, because usually this case, that means it's a little bit deviated from the mean, so that we can fix a certain problem, then this distribution will move to the left very easily. But process C, in terms of average, is very great, but standard deviation is too large. That means there should be some more difficult problem to solve this problem, because usually it's really hard to make a narrow deviation. It's much harder than the squeezing the mean. So in this case I will choose A instead of C. C is much easier to move to the left side if we found the problems than the C. Okay. This is a real example in Toyota. Toyota makes 13,000 vehicles per day, but they are very famous for quality, you know, because this system, if there is an expert and they found problems in the manufacturing process, and they pull the line here, there is on the top there is a line, and if expert pull the line, all the line will be stopped because the expert found problems. Okay, so that they stop the production and try to find the problem and solve the problem. All right, we call it andon. I think it's Japanese word, andon. So this rope, call it andon. So Toyota, they always try to make a high quality vehicle without any defeats. Okay, so they want to achieve 6 Sigma level in the manufacturing process. Does it make sense? Okay. So let's look at the quality control. We have a machine. This machine can generate the bolt with 1 inch length. The process at the beginning, okay, it's fine. The mean is 1 inch and standard deviation 0.01 inch is acceptable. But after this machine working, like machine generate 100,000 bolts, okay, it takes a long time, and the machine went wrong. So you can see after the generating 100,000 bolts, the mean is a little bit skewed to the narrow, the more smaller side, like 0.95 inches. It's decreased, and the standard deviation wise it's increased, okay, 0.02 inches. Alright, so what we need to do is we have to check the machine's circumstance, machine's condition, to try not to make a defeat or some malfunctional product. So we always check the length of the bolt, okay, after a certain amount of time, certain amount of generations. Let's look at the control chart, statistical process control chart. We call it SPC chart. Here you can see the bolt length should be 1 inch. Okay, this is the mean, 1 inch, and this is standard deviations. Alright, that's standard deviation. It looks like these data are pretty much beyond the mean. Okay, it's more bigger than mean plus 1 standard deviations. So this is a problem. So SPC is a method of controlling and improving a manufacturing process. Here the x-axis shows time, so 1 minute, 2 minutes, 3 minutes. So we can see the time and the bolt length. The target is 1 inch, right? And this blue line shows 1 standard deviation, red line shows 2 standard deviation, and the orange line shows 3 standard deviations. So zone C, zone B, and zone A. There is a rule to use this SPC chart to evaluate whether the process is in control or not. Nielsen in 1984, he defined 8 rules, okay, to judge or evaluate whether this process is in control or not. Okay, so rule number 1 is, you can see here we have some data here, and this is target, 1 standard deviation, 2 standard deviation, and 3 standard deviation. But this data of 0.4 anywhere beyond zone A, this is a problem. Okay. How about the rule number 2? Rule number 2 is 9 points in a row occur on the same side of the mean. So here this is the mean. Actually this is target, but 9 data points in a row occurred bottom side, not the top side. Rule number 3, 6 points occurred with a consistently decreasing or increasing. So you can see decreasing pattern. So if there shows some decreasing pattern, okay, the machine has some issues. Rule number 4, 14 points in a row alternate from one side to the other side. Okay, you can see. So alternatively happened, and still is increasing. The distribution is getting increasing, okay, from the target, so that we can say, oh, okay, this machine has some issues. How about this one? 2 data out of 3 are in the zone A. Okay, this is the problem. How about rule number 6? Rule number 6 is 4 data out of 5 happens in zone B. Okay. How about the rule number 7? Target is here. Every data is on the top side. 15 points in a row occur in zone C. Okay, rule number 8. Rule number 8 is you can see the huge deviations. So 8 points in a row occur beyond zone C. Alright, it's good. So let's look at some example. We have a reactor temperature, and here you can see the x-axis shows timeline and the y-axis shows the temperature in Fahrenheit degree. Okay, so 40 degree is the target average. And then let's evaluate this process, whether this process is in statistically controlled or not. Let's assume the standard deviation is 2 degree Fahrenheit. Okay, so 1 standard deviation, 2 standard deviation, and 3 standard deviation. Is this process in controlled or not? Based on the Nielsen's 8 rules. Here you can see with a standard deviation 2 degree Fahrenheit. Okay, this data is against the rule number 1. Okay, it's beyond the zone C, right? And the rule number 3 is 6 data points increasing or decreasing pattern. In this case, it's increasing pattern. So there are some issues. Rule number 5, 2 out of 3 data occurred in zone A area, zone C area. Okay. How about if we set 5 degree in Fahrenheit as a standard deviation? 1 standard deviation, 2 standard deviation, and 3 standard deviations. Okay, in this case we still have some issues because some data points increasing pattern and the 2 out of 3 data occurred in zone C. Okay, so that's it. Lastly, I want to introduce a Minitab software. We call it Minitab. This is a very strong statistical software. You can solve many statistical problems using Excel, but Minitab is more powerful and more catering toward the statistics part. So here you can see some chart. So SPC chart. You can generate histogram, SPC chart, or any kind of a chart. And this is free. You can download it for 30 days trials. It's free. It's very useful tools. Okay, today we learned 3 things. First one is no difference between population and the samples and how to select the samples. And second one is we understand what is the descriptive statistics, how to calculate the mean, median, and mode standard deviations. The last concept, we know the statistical process control chart, SPC chart, how to evaluate whether this process is in control or not using the SPC chart. Thank you for watching this short video and have a great day.